Good morning to all the students. In the previous lectures, we have discussed the methods to solve nonlinear equations. The methods discussed by us were the graphical method, bisection method, regular-Falsy method, and Newton-Raphson method. In this lecture, we will discuss the second method. This method is similar and improved method over regular-Falsy method. Here, it is not necessary to fulfill the condition fx1 into fx2 is less than 0. In this method, the graph of fx is approximated by a second line. The root may or may not lie in the interval a comma b. So the formula used by us in this method is same as that we have used in the regular-Falsy method. That is, the first approximation x1 is equals to AFB minus BFA divided by FB minus FA. The second approximation, for second approximation, we take the points as B and x1, and the second approximation becomes BFX1 minus x1 FB divided by fx1 minus FB. For the third approximation, we have taken the points as x1 x2, so x1 fx2 minus x2 fx1 divided by fx2 minus fx1 is equals to x3, and we will if xn minus 1 is equals to fxn, then the method fails, but the rate of convergence in second method is greater than that of a regular-Falsy. In the right hand side, you can see a diagram which shows that for the first time during the first iteration we have taken the points as a and b. For the second time we have taken b and fx1. For the third time we have taken x1 and x2. For the fourth time we have taken x2 and x3, and for the fifth time we have taken x3 and x4. In this case we have not considered the concept that function at a into function at b is less than 0, and further also, that is f of b into fx1, for the second time we haven't checked that whether it is less than 0 or not. So this condition may be neglected in case of second method. Next, geometrical interpretation of second method. In the figure, the line segment joining x0, fx0 and x1 comma fx1 intersects the x-axis at point x is equals to x2. Again, the line segment joining x1 fx1 and x2 fx2 intersects the x-axis at the point x3. We continue this process. Again, we form a line joining the points x3 and x4. It meets the x-axis at point x4, and then we proceed in this way, and finally the intersecting point approaches the root. There is a point to remember. In the regular-Falsy method, the 2 points are chosen so that the root lies in the interval xi minus 1 xi, and the product fa fb is always less than 0. But second method may or may not follow the above conditions. So we consider example. Find the root of the equation x exponential x is equals to cos x using second method to 4 decimal places. So here we have assumed that let fx is equals to cos x minus x exponential x. Taking the initial approximate root, a is equals to 0 and b is equals to 1. We check the value of the function at f0, it is 1, and at f1 it is negative of 2.178. Again, cos 1 is calculated in terms of radians. So by second method, x1 is equals to AFB minus BFA upon FB minus FA, which is equals to 0 into f1 minus 1 into f0 upon f1 minus f0. We have substituted the values of the terms, and x1 comes out to be 0.3147. Again, we calculate the value of the function at 0.3147, and we calculate the next approximation x2 as 1 into function at 0.3147 minus 0.3147 into f1 divided by f of 0.3147 minus f1. Again, we have not checked here the condition that the function at 0.3147 into function at f1 is less than 0 or more than 0. It comes out to be less than 0, but we haven't checked that. So again, the value of x2 is 0.4467. Next, we calculate the value. Again, we take a as 0.3147 and b as 0.4467. Again, we haven't checked that whether the product fa into fb is less than 0 or more than 0. In this case, at 0.3147 it is positive, and at 0.4467 it is also positive. It is again positive, but we haven't checked that. We have simply substituted. So on substituting all the values in the formula, we get the value of x3 as 0.53169. Similarly, we have proceeded further. On the right hand side, I have drawn the diagram how we have considered the pairs. So by solving, we get the correct root as 0.5178. Thank you.